Good morning. So today's lesson is all about slope. And if you follow along with me in chapter 5.1, page 256, that's where I'm going off of. All right, so the definition of slope is rise over run. Another definition of slope is just a general word, means it's steepness. So what I mean by that, so just making a quick graph. So, talking about slope, we have two lines. One of them, you would agree, is more steep than the other. So when we're talking about the steepness, which obviously hopefully we would all agree that this is the more steep one, then that is what we're also describing the slope, that this has a greater slope than, say, this one. And so then there's a mathematical way to find that. It's the change in y over the change in x. So these are three different definitions of slope. So sometimes I'll interchange them with each other. And the mathematical equation for it is m is equal to y2 minus y1 over x2 minus x1. M stands for slope. And then the y2, y1, x2, and x1, those are the coordinates, and we'll go over that when we're actually doing our examples. So, example 1. Right now, I am doing the example from your book, example 1 on page 257. It gives us these coordinates, -1 and 2, 3 and 4. Hopefully y'all can see that. Let me just move that down a little bit. So this is coming from your book. And so it gives us these coordinates. So this is one coordinate, and this is this is the first set of coordinates, and this is the second set of coordinates. There's a couple different ways to find slope. I call this way the visual way. Visual means that I'm going to go ahead and graph these points and find the slope visually, or by looking at it. So I'm going to go ahead and graph these points. -1, +2. So I go backwards 1 and up 2. Then the other one is 3, 4. I go over 3, up 4. And that would make this line. So to find the slope, visually, I'm doing rise over the run. So I'm looking at this dot, and I want to count how many times it takes to get to this dot. So rise means I'm going up or down. So I'm going to go up 1, 2. See how it's 1, 2, so that it's even. Since I went up, it's +2. Now I'm going to count how many to go over. 1, 2, 3, 4. Since I went to the right, it's +4. So it's 2 over 4, and I reduce that to 1/2. So that is what I call the visual way, because I'm visually counting up and then over. So, and then that's it. Your slope is 1/2 for this one. Now, 2 rules. We always reduce it, but you never change to a mixed number or a decimal. So for example, if I had one that was 5/3, I don't change that to 1 2/3. I leave it as 5/3. All right, so let's try another one. So this one, I'm not naming any points. I'm just drawing a line, and you'll see something like this on your IXL where they give you a line. So it looks like this. All right, so here we go. So it's kind of like reading a map almost, that I'm at this coordinate and I want to get to this coordinate. And so actually I just thought of a question that somebody might be thinking. Does it make a difference if I go from here to here? Nope. It's a little bit more, you have to be careful about positive and negative signs, but it doesn't matter if you start from here and go to here or start from here and go to here. I always start with the dot on the left because I think of reading. When I'm reading, I read from left to right. So when I'm reading my coordinates, I go from left to right. And it makes it easier with signs and stuff like that. So it doesn't matter, you'd get the same answer. So here we go. I'm going from here to here. So I go up, 1, 2. So it's always rise over run. So I went up 2, and then I go over 1, 2, 3, 4, 5, 6, 7. So it's 2/7. We don't have to reduce on that one. So to save me some time, if it's okay, I'm going to use the same line right here, and I'll just do a different color so it's more obvious. And I would love to be using my smartboard, but it doesn't seem to be cooperating. So so let's do this one. All right. This time, again, rise over run. Now, rise doesn't technically mean, are we always going up? Like rise meaning going up. Rise for this case, means just we're going up and down, and then we're going over. So we would go down this, we are here and we want to go here. So we would go down 1. So that's down. Since we went down 1, that's a -1. Since we went down, it's negative this time. And then we go over 1, 2, 3, 4, 5, 6, 7, 8. And that's your answer, -1/8. So if you go down, it's negative, and then you just count over. Okay, so now I want to show you, I was previewing your IXL last night, and what is nice about the ones that I gave you is that we have nice clear dots. They're not always going to give that to you. Sometimes they're just going to give you a line, and you still have to figure out what the slope is without that line. Okay. So this time, as you can see, there's no dots. This is the most common time when people are going to have the hardest time. You have to find where you should put a dot. So the easiest thing now that I think of to find it is looking for the crosshairs. You want to see Where is it crossing the T? So, for example, right here, it's not crossing, I don't know if I'll zoom in. So right here, it's just in the middle of nowhere. It's in between these two lines. But look right there. See how it's touching the crosshairs? It's like crossing right in the T. You're looking for where you can put a dot on the T. So I'm going down the line. I can't put a dot there because as you can see, it's in between this line and this line. So I'm going down the line and I'm looking for where, ding, right there. See how it's crossing right there? Now on your IXL, you're not going to probably be able to put those dots, but for my instruction, I'm putting those dots there so you can see where I'm counting from. So you're looking for the crosshairs. What I mean by crosshairs is like the target or a T. All right, and then we count from there. So this time we're going from here to here. So I'm going always up and down, and then I'm going over. So up and down, so this time we are going down to get to here. So we go down 1, 2, 3, 4. So that was down 4. So 1, 2, 3, 4. And then I go over 1, 2, 3. And then that's your answer, -4/3. You can't reduce it. There's nothing that will go into 4 and 3. And like I said earlier, you never change it into a mixed number. So you're not going to change it into -1 and 1/3. You leave it as -4/3. The reason for that is because if we change that, we don't have a clear rise. If you change that to 1 and 1/3, that's not telling you how many to go up and over. It could be confusing. So we just leave it like this. I'm going to make a separate video using the mathematical equation. So I call this, now this is not mathematically correct speaking, I call this the visual way. I'm just counting versus using the equation, which will be on my next video.